Hello, 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 everybody. Sorry for the delay in posting this. I was working on my dissertation and had to finish it. I even, in my old age, pulled an all-nighter. So now I'm good to go. I'm done with that, thankfully, and I can turn my attentions to you. Although I do have to defend here coming up soon, so that's a thing. Um, One more thing. Yes, I know I always wear this sweater in these videos. Look, it's my comfy home sweater, okay? It's fine. It's clean. You know, I wash it. So stop judging me. Uh, okay, I might have to break this lecture into a couple of parts because it can be kind of long. So last time I kind of gave an overview of the history of the concept of race. Like a short overview, to be honest with you. And as you can see up here in this first slide, those five skulls are from Johann Blumenbach, who we talked about last time. So we're going to basically break down the question of whether or not there's any kind of biological validity to this idea of race. Like what does it mean? And based on what it means when we look at the data, does that hold true? Okay, so I obviously have this picture at the bottom because one of the first things that people say when you ask them, like, well, what is race, is they talk about skin color. And obviously there's not just 2, 3, 4, 5 skin colors, right? You can see sort of like a gradual change in skin color. There's so many, it's hard to actually put a number on it, right? So it's got to be more complicated than that. So in defining the concept, what I'm doing is I'm not saying what it actually like what the truth of the matter is. I'm saying what have most people meant when they have talked about race? Like if it's going to have any meaning at all, what are the ways in which people are defining it? Like how many would there be, right? There has to be some kind of criteria for a race, right, in order for it to be a thing that has meaning. So let's talk about the assumptions that most people build into this, or have. Things obviously have changed over the last several decades, but of course, a lot of these assumptions are still made by people. The first assumption is essentially that race is biological, by which we mean genetic, right? Race isn't like learning a language, right? You can't really change your race. Although I know there are pop culture figures who, if you guys, what was that woman's name? The one who got in a lot of trouble a while back because she was leading a chapter of the NAACP, and it turned out she was white. It's not really a thing that you can choose, right? So there's an assumption that it has a biological basis. Okay. Another thing that historically people have assumed is that it not only encapsulates something outwardly physical about you, but it relates to psychological characteristics, mental characteristics, social characteristics. Especially in the early days of this notion of race, like we talked about last time, people tried to put personality, temperament, IQ, even though IQ wasn't really defined back then, but just intellect. So there's an assumption that that's baked into this sort of biological cake, right? And you can separate people by these characteristics into clear groups. The other assumption that I think is made, even though people might not articulate it, is that any two people within this group that is a race A, are going to be more alike one another than any of them in this group are to group B, right? So if there are races, and races are groups, and these groups are based on um, some kind of biological affinity, uh, then like they would have to have like a boundary, right? You would have to be able to clearly say, oh, this person is in group A because of these things, right? And this person is in group B because of these things, and could you really be in both? I know people talk about being mixed race and things like that, but that's basically just taking a little column A, a little column B. Um, so in order for this to have any meaning whatsoever, uh, you would have to assume that there's something more similar about people in this group, um, and more similar about people in this group than they have in common, right? That would be the assumption. Um, Similar to that is that it's natural. It's just part of the makeup of mankind. It's discrete, meaning it doesn't really blend. There's this group, there's this group, there's this group, um, and the boundaries are clear between them. Right now, I want to make this very clear, since I'm not talking to you in person in class, since you are studying at home. These are not things that I am saying are true. These are like, if we had to define what does race mean, these are the things that people have historically put into that definition, right? These are assumptions, and what we're going to do is we're going to go through and kind of look at the data and say, does the data support these assumptions? So first we have to kind of go back and do a little bit of review of some population genetics. So when we're looking at data that has to do with race, we talk about populations. Well, what exactly is a population? Well, it could be like a group of people living in a geographic region. Now, how that region is defined is up to you, right? It could be people living in Las Vegas. It could be people living in Nevada. It could be people on, the western half of the continent. It could be all of the United States. It could be North America. It could be your neighborhood, right? However you want to define it. Usually we're talking about a group of people in a geographic region. Now, in terms of like population genetics, when we define a population, it's usually a group of people who could plausibly mate with one another, right? So taking like a person, like before modern travel, taking a person from California and a person from Siberia and, putting them into a population for the purposes of population genetic analysis, that doesn't really make sense. Because, if they can't meet up, they can't mate, yada, yada, right? But really, it's arbitrarily defined. How you want to define your region, how you want to separate out the people in that region. Are you going to define it based on skin color? Are you going to define it based on height? Are you going to define it based on sex, like biological sex? Are you going to, it's arbitrary. The choice of how you define a population really depends on what's the question that you're trying to ask. And of course, like Soylent Green, it's people. So population geneticists also talk about population structure. What is population structure? It might be helpful first to talk about what it isn't. Panmixia is a theoretical term which describes a situation in which all people have an equal probability of mating with one another. All people of reproductive age. And when we say mating, not not like, hooking up with someone at the club, but, having children with someone, right? So panmixia is a situation where people are not assorting in a particular way, like only choosing mates who are the same religion as you, or speak the same language as you, or are in a similar socioeconomic status or whatever. In theory, panmixia means that any person is just as good as another for mating, and people aren't picky. Hey, nice yoga pants. Um, so that is that. If there is a situation in which there's panmixia and people are just randomly just kind of mixing together and everybody has the same number of kids and all this stuff, you're not going to get population structure. You're going to get a homogeneous population, right? So population structure, I like to think of like lumpy mashed potatoes, okay, where your population in this case is your bowl of mashed potatoes. The structure is literally like the structure of the mashed potatoes. Like there are some parts that are kind of more sticking together a little bit, but they're still connected to the rest of it. You know, you'll find dense areas here, less dense areas over here, more dense areas, etc. So it's sort of like a topographical map, you know. So population structure, whoops, let me go back here. It really just means that some people, some parts of the population might be slightly more closely related than other parts of the population, right? So it's not a smooth mixture. You can't necessarily disentangle all the pieces of it, but there are kind of zones of difference that you can see. Yeah. So how do you get population structure? Basically through evolution. And by evolution, I mean the four forces of evolution. I don't mean just adaptation. So one of those is sortative mating, which is what humans tend to do. When you are more likely to mate with individuals who are more similar to you. You know, like I said, people who live either geographically close to you, which makes sense. People who share certain values with you, who understand the world in a certain way as you. You know, whether it's marriage defined through kinship structures, arranged marriages, marrying someone that you meet at work, marrying someone that you meet at school, you know, that is not a situation in which everybody has an equal chance of kind of mixing their genes together, right? Another one is natural selection, right? So if you're living in a similar environment that poses similar challenges and obstacles, and that sets up a selection pressure for certain traits that are in the population, like people in a similar geographic region will tend to be in the same circumstances, and the trait might spread among people in that particular region, right? So like those peppered moths that we talked about. Genetic drift is another one. So remember that genetic drift is about random fluctuations in allele frequencies. Like, oh, maybe you have a blue-eyed allele floating around in your family. You know, your grandma had blue eyes, but you don't have blue eyes. Maybe you don't even have the allele, so you can't pass it on to your kids. You know, it drops out of your line because you can't pass it on to your kids. Or things like founder effect, right, where the French-Canadian population came from France but didn't represent all of the genetic diversity that you could find in France, but a sampling of it, right? Or, you know, natural disasters, catastrophes, where just randomly it happens to knock out a higher frequency of some traits than others, right? Like these poor green beetles, you know, after they accidentally got stepped on, not because they're green, but because this jerk wasn't looking. You know, now the population only has 1 green and 6 brown, and then later on, you know, maybe the green will drop out. Or genetic bottleneck, which tends to do the same thing. We've got a parent population that has a lot of variation in it, and because of who knows what, famine, drought, disease, you know, it winnows the population down to a very small population, and the ones that survive, who are falling out there into the glass, the makeup of that population is different on average than the makeup of the parent population, right? In these surviving individuals, you've got majority blue marbles, whereas in the parent population in the bottle, there's a, you know, equal distribution of yellow and blue. Okay. Also, uneven gene flow. What does that mean? It basically, gene flow, remember, is the transfer of alleles between populations. So if there's some kind of barrier that prevents that gene flow, or if flow goes mainly in one direction but not in the other, you can get changes, right? So that's how you get population structure. So let's take a look at human biological variation. Sorry, I'm looking at my phone because I'm timing myself. So in general, humans are 99% similar on genetic level. So that means if you go through every letter of the genetic code, 99.9% of those are the same for everybody. For humans and chimps, it's 98.8, right? So we're pretty damn similar to chimps too. I don't know if this number is still current, about 10 million SNPs. I think that's low. I think they found several million more than that at this point, but there's more single nucleotide polymorphisms, but it's still a very low number compared to the billions and billions of base pairs in the genetic code. Then don't forget about things like pleiotropy, where one trait, one allele, one area of the genome can affect multiple other areas of the genome. There's polygenic traits like height that are influenced by hundreds or thousands of genes in the genome, right? It's not just, oh, you have the tall gene, oh, you have the short gene, right? There's hundreds and thousands of them really throughout the genome that affect height, plus the environment, your nutrition and so forth. Epigenetics really has to do with how the environment interacts with your genome. So those last two are quite similar. So it's not so complicated as, you have this gene, that means you're going to be in finance, and you're going to marry someone who is 2 years older than you, and you're going to have a house with 1,000 square feet. It doesn't work that way. It's very complicated, right? So let's look at skin color, right? Because the first thing that comes to people's minds, like I said, when usually they're asked about, like, hey, what is race, is skin color. Well, anyone who hasn't been living under a rock knows that skin color doesn't just come in like 3 shades. It's clinal, and clinal means, think of an incline. Instead of like an incline, like a wheelchair ramp or something like that, as opposed to stairs, right? Where there's instead of there being one stair here in an incline, right? You have like pavement or a ramp that goes all the way. There's no discrete breaks in it, right? Clinal means something similar, that there's a gradual change from one thing to another thing, right? And it's very difficult to separate where one ends and the other begins. So skin color is clinal. This picture here is not of really detailed resolution, right? If you look at the number of categories that they break down skin color into, they go by, like, there's 1 through 12, whatever those numbers represent, are represented by a single color, right? Then 12 through 14 are another color, 15 through 17 are another color. So you could make even finer steps there, and you would see in this picture how gradually some of those changes are made, right? And how complex the picture is. But even this gives some idea of it, right? We should all know at this point that skin colors within the tropics tend to be darker shades, and the further away you get from the equator, on average, the lighter skin color becomes in both directions, but more of the Earth's landmass is above the equator than below the equator. So most of the darker skin tones are within the tropics, okay? And that's because of natural selection, right? So essentially, having darker skin color, as we know, protects you from things like skin cancer. Yes, one thing, but also less credit is given to things like sunburn. Sunburn, dehydrates your skin. It irritates your skin. And if you're, back in the day, before, modern conveniences and hospitals and things like that, being sunburned on a regular basis is not great for you. You can get dehydrated very quickly, and also if too much UV light penetrates your skin, it depletes folate in your blood, and folate is something that's needed for health, essentially, and in particular for pregnant women. It's very important for the baby. So it's a super important thing, and having darker skin actually sort of protects you from absorbing too much of the UV radiation, right? So it makes sense. Whereas the further away from the equator you go in either direction, the less direct sunlight you're getting throughout the course of the year, and you need some UV radiation to penetrate your skin, because the interaction of that UV radiation and certain compounds in your body enables you to produce vitamin D, and vitamin D is necessary for the uptake of calcium in your body. So without vitamin D, you can ingest as much calcium as you want and your body can't use it. So people with severe vitamin D deficiency can get something called rickets, where the bones are malformed. And actually it can be so severe that it's difficult to give birth. It can also affect your nervous system. There's a whole host of things that can go wrong. So in places with less sunlight on average, you have lighter skin colors so that more of that UV radiation can penetrate. Okay. Now, if race based on skin color were a thing, right? In one race, you would not only have some sub-Saharan African populations, but you'd also have like indigenous Australians. You'd have South Indians. You'd have people in New Guinea, people in islands in Melanesia, even in the southern part of the Philippines, would all be, one race, right? If lighter skin colors were one race, you would have Southern Europeans, West Asians, and in fact a large variety of Asia and North America all in one race, right? If the intermediate skin tones were a race, then you'd have people from North America and South America, people from Northern Africa, India, parts of the Arabian Peninsula, Thailand, they would all be one race. So clearly, skin color as being the defining thing for a race can't be, right? There are people from widely different areas that share similar skin tones. Also, there was a study done that I was going to have you read for class, where they measured in dozens of populations. So each one of these lines and dots represents one population here. And the dot represents the average skin tone, the average skin reflectance. It was measured with a special thing that measures how much light is reflected off of skin. So the dark dot represents the average, and the line represents the range of skin tones in that population. And you'll see that every single population here overlaps with its neighboring population. So there are no discrete breaks in this graph. The closest that you get is kind of in this area here, because you see the averages are different, but the ranges still overlap, right? So there's no like populations where you can say, oh, those neighboring populations are completely different in skin tone, right? So that's not a great way to define it. We're going to take a little tour around the world, so you can kind of, as if you're walking throughout the world, so you can get an idea of even just phenotypical variation. But I think I'm going to break up this video here, and I will be back with the second half of the video, okay? So stick around.